Assalamualaikum warahmatullahi wabarakatuh, and hi to my lecturer Cikgu Saufan and also to my fellow friends. So today I would like to present about the application of mathematics, which is in natural science, which is in physics. But before I start my presentation, let me introduce myself first. Hello, my name is Hasha binti Muhammad Hazori. You all can call me Asha. I am from Mathematics 3 and I am PPICMP 2429. Okay, so today's agenda, we are going to discuss about the application of maths in real life scenario. And the second one is the application of mathematics in physics, which is in Hooke's law. The topic I choose, of course you guys wonder, right? And the third one is the application of Hooke's law in real world context. And the fourth one is the fundamental of mathematics on understanding the area of the Hooke's law. And the last one we are going to conclusion. So let's go. But before I start my presentation, I'm sorry if you guys cannot see my slide fully because I have a little bit of technician problem. Okay, so let's continue. So this is actually about the application of mathematics in real life scenario. So mathematics is often viewed as an abstract and also theoretical subject. For example, for academic purpose, for examination, and of course I also think that like that way because I think that mathematics is actually only used for academic, only for us to study examination, to get a good school, and to make our parents proud, right? But actually, mathematics enables people to analyze, organize, and observe the different activities that are encountered in our daily life. For example, if we want to buy our favorite things, of course we are going to budget our expenses, right? We are going to collect the money and budgeting our expenses. And if you want to baking or making a cake, of course we need to measure in the ingredients. And if we want to travel, of course we wonder about the distance of our destination. So all of this actually apply mathematics and so on. So in conclusion, mathematics is deeply involved in people's daily activity, or in easy word I can see it's actually involved in everyone's daily activity, as it is necessary for life. Even if we want to buy or sell, of course we apply maths because we need to exchange our money with the things we bought. So next, we are going to see about the Hooke's law, which is the application of mathematics in natural science, which is in physics. So this is the topic I choose, which is the Hooke's law. So what is this actually? So let's look together. So this is the Hooke's law, and you can see this is actually the Hooke's law. Okay, so Hooke's law is the formula of Hooke's law is F equals to negative K times with H. So what is this actually? So F is represented as a force needed to extend or compress a spring. And this Hooke's law actually describes a linear relationship between restoring forces, which is F, and displacement from its equilibrium position, X. X is actually represent the extension of the spring. And the K is the spring constant, which is the stiffness of the spring. So this is just the question from me. So what is actually this Hooke's law used for? So as I said just now about what is actually Hooke's law, so I think you guys can guess what is it. So there is three options I put here, which is the first one swimming, the second one elasticity, and the third one is running. So what actually you can relate the spring with? So what do you think? So the answer is the second one, the elasticity. Of course, the elasticity when it comes to spring, right? So then we are going to know who actually the genius that found this law. So the genius that found this law is this one. Okay, his name is Robert Hooke, and he is actually a British physicist, and he discovered this relationship around 1660. So he stated it first with Latin anagram, which is attention, sit, please. I don't know if I pronounce it correctly or not, but if it's wrong, I'm sorry. But the meaning is as the attention, so the first. And his findings were critical during this scientific revolution, and is actually leading and separate to the whole world about his law, and it's actually leading to the invention of many modern devices, for example portable clocks and also the pressure gauges. And this, as you can see here, the Hooke's law is based on his name, Robert Hooke. So let's see the next one, which is the application of Hooke's law in the real world context. So the first example I can determine here is the shock absorber, which is this one is used for car. So we use the coil spring to absorb the shock and vibration from the road surface. Okay, I'm sorry for the typo. And as you can see, the coil spring, of course, is related to Hooke's law. Okay, and the spring compress and store the potential energy when the vehicle hits an uneven surface, or maybe when the car or the lorry, the van hit the rough surface or not a smooth surface. So this Hooke's law, which is the coil springs, actually enable the vehicle to move smoothly and under control, and this actually help the car or the individual from accident. So you can see the benefits, right? So the next one, we have watch and clock. So the balance wheel is fitted with a balance spring, also known as hairspring, which is usually composed of a highly elastic material like steel. So the spring stretches and contracts as the balance wheel oscillates back and front, applying a restoring force. And of course, we can see our analog watch moving, the needle moving. So it's actually ensure the timekeeping mechanism move precisely and on schedule. So the function is actually to ensure the time is on time. So it means the time that we are going to see is on the right time. Okay. So the next one, we have the last one here, which is the trampoline. So the trampoline is actually an interesting activity to do with our siblings, right? So the trampoline here is actually an elastic disc that is connected to several springs. So it has a lot of springs around it. Okay, as you land on the trampoline, the springs, and the trampoline surface stretch as a result of the force of your body landing on it. So when you land on the trampoline, so then the trampoline is stretched. And in other words, I can say the spring will pull back against the weight of your body as you land. So if you landed on the trampoline, sometimes you will feel like you are flying, right? Because you are pulling back to the upwards. Okay, then we're going to the next one, which is the equation. So here I just want to give a more information. This is just what I add about the equation. So as we just look at just now about the formula S equals to negative Ks, this is just an extra information. So F, as we know, is a force applied, and it's used a Newton unit. and the K is spring constant. We use Newton per meter, and the S is the extension of the spring, which is in meter. And as we know, F is equal to the mass of the object multiplied by the acceleration due to the gravity. And this is the basic knowledge, which is F, the force, is equal to our mass and times with the gravitational. So, and this equation could also be written like this, or could also be modified like this, which is negative kx, which is the Hooke's law, which it will equal to the mg, so the force. So it's just the same. So next we are going to do y, which is the. Okay, this is the example of the question based on this Hooke's law. So let's see together with me. I'm sorry again with this problem. Okay, the question. A trampoline has a spring stiffness constant, which is K is equal to 4,500 Newton per meter. So a person weighing 780 Newton stands on it, which is on the trampoline. So how far will the trampoline go down? So let's calculate together. So as we know, the Hooke's law formula is F equals to negative Ks. So the calculation method for the first step is we are going to write the formula and modify the formula as the subject, because we are going to find the extension of the spring, right? So we need to make the S as a subject. So the formula, the normal formula is F equal to negative Ks. And when we modify it as S equal to the subject, S is equal to negative F over K, which is the constant. So then, what we need to do next? So we substitute the value for each variable. So for the K is given, which is 4,500 Newton per meter. I'm sorry. And for the force, which is 780 Newton. So just substitute the value and don't make a mistake. Be careful. And then we just calculate it on our calculator, and we got the answer, which is x equals to negative 0.1733 meter, which is equals to negative 17.33 centimeter, which the sign of the negative sign indicates that the trampoline moves downward. So the negative sign here just represent the downward movement. So therefore the trampoline goes down as much as about 17.33 centimeters. So that's the answer. Easy, right? So let's go to the next one. So this is actually the last agenda, but we have conclusion, and this is the second lesson. Okay, so this is the evaluation on how actually mathematics are fundamental to understand the area of the Hooke's law application. So let's look at together. So it's actually help calculating the extension, elasticity, and forces that apply. So based on the graph, as you can see the graph at your right side, okay, there, this is the Hooke's law graph, and as you can see there is elastic limit, and based on the graph, okay, the limits of the elasticity in material can be determined, where it helps to prevent the mechanical failure. So this is also the mathematical tools we use right now, which is the graph, and it's actually made the scientists, the engineer easy to create something or innovation or something else like that. And then we have also in robotic industry, which Hooke's law is applied. Okay, Hooke's law is used to design the actuators and suspension systems that require predictable elastic properties. Also, okay, I'm sorry for the typo again. Also, this Hooke's law used to model and optimize the robotic movement. Of course, when we are talking about Hooke's law, it's about spring. Of course, it's about the movement of the robot. Of course, the movement of the arms, the movement of the body. So this Hooke's law is actually applied to make a robot, to make a robotic thing, to make about a computer things like robot, and things that same as that. Okay. Then we are going to the next fundamental, which is Hooke's law that also apply in study of biological tissue, such as ligaments and bones, to understand the elasticity and mechanical limits. And for your information, we can just see it here. So it's actually show our bones, ligaments, and we cannot see it with our eyes, but it actually is in our hands. There is ligaments, bones, and also the tissue, which is also applied as Hooke's law. Okay, the elasticity here. Okay, and there is the example of the picture: tissue, ligaments, and the bones. Okay. Okay, so we are going to the conclusion. So in conclusion, what we learned here. So in conclusion, what I can say here, application of mathematics is actually crucial in this science field, especially in real life scenario in our daily life, because I think we apply mathematics everywhere and every time. Okay, based on this Hooke's law application, we know that when we supply some external forces on the body, it differs from its original shape and size. So by using this mathematical formula that we just learned just now, which is F equals to K times X, engineers and scientists can design and analyze systems involving spring elasticity and material behavior. So this principle is widely applied in engineering, construction, automotive suspension systems, and the others. So mathematics actually helps us in precisely calculating forces, predicting deformation, and ensuring safety and efficiency in structures and mechanical systems. So without mathematical modeling of Hooke's law, I think that designing reliable and functional products in industry like aerospace, civil engineering, and medical devices would be so challenging, right? So thus, mathematics is essential for applying Hooke's law effectively in solving real-world problems. So I hope this video could give good information, a good knowledge for all of you. And if this is a good information or good knowledge, I hope you guys can share and subscribe this video. So that's all from me. I hope you guys gain something, and bye bye. I hope we can see in the next video. Bye bye. Thank you for watching.